Hey Algebra 2 folks, how we doing today? Alright, we're getting towards the end here. We're dealing with fractions and now we're going to be dealing with adding and subtracting. So we were multiplying and dividing. The previous lesson we talked about inverse variations and graphs and branches and asymptotes on both the x and y axis, holes and vertical asymptotes and horizontal asymptotes. So now we're into the last bit of this chapter dealing with rational expressions, adding and subtracting, and then at the end here we'll do equation solving with fractions in them. So just a quick little warm-up here, just to refresh your memory on how we add fractions. So if I have 1/5 plus 2/3, unlike multiplication and division where we can look for cancellations and simplifications, here we've got to find what's called the least common denominator. In other words, I've got to make 5 and 3 go into some kind of number that is going to be common for both fractions. So I will need something that 5 goes into, something that 3 goes into. They're both prime, so it's going to be 15 for my least common denominator. It's also called the least common multiple. And so in doing this, I'm going to say what multiplied by 5 will give me my 15, and so that's 3. So I'm going to multiply top and bottom by 3 to make that into 15ths. And then I'm going to do the same thing with the 2/3 fraction, multiply the top and bottom by 5. Notice when I do top and bottom of the same thing, that's just multiplying by 1, and it doesn't change the value. It's going to be 2/3, it's just going to be 10/15ths, which is 2/3 reduced. And so then I multiply top times top and I get 3/15ths. That's the same as 1/5. It's just 3 out of 15 instead of 1 out of 5. It's the same ratio. And then we get a 10/15ths for my second result. And now that they have common denominators, we can put them together and get 13/15ths. So that's with numbers. Let's do another warm-up here where it's fractions. With letters, I should say. And so now I'm looking at x and y. What's the common denominator? Least common denominator would just be xy. So I'm missing a y for this first fraction, so I'm going to multiply the top and bottom by y. That's still legal. We won't worry about restrictions on these problems. And then I've got 3 over y, so I'm going to need an x with this denominator to make it the least common denominator, xy as well. So what I do to the top, I do to the bottom. That keeps that fraction the same value. And now I get a 2y on the top, a plus 3x for my second part on the top, and then all over that common denominator. And we usually go alpha order when they're the degrees are tied there, so xy is a little bit better than yx. Obviously wouldn't be wrong the other way around. And there you have it, final answer for that one. So those are a couple of warm-up problems for us. They get a little more involved. Let's just review least common multiple one more time. So least common multiple, that's the least common denominator when you're in a fraction of two numbers, say 2 and 8. So what's the least common denominator if we had 2 and 8 as the denominators, or the least common multiple if I had 2 and 8 as the numbers? And so this 2 is prime, so it's just 1, 2. This 8 is not prime, it's actually 3 2's. So here's the prime factorization. 2 is prime, so it's just 2. 8's 3 2's multiplied together. To build or make my least common multiple, I need all the pieces to make either one, but no repeats. So if I take these 3 2's, that'll make the 8, will also make that 2. So that's my least common denominator, or least common multiple, which is 2 times 2 times 2, or 8. All right, let's try a couple more of these. How about 6 and 10? All right, so this is going to be 2 times 3 for its prime factorization. 10 is going to be 2 times 5. That's going to be its prime factorization. And now that LCD or the LCM, depending if you're a fraction or not, will have all the pieces to make either one of these with the fewest number possible. So each of them need a 2, so that's going to be part of it. I need a 3 to build the 6, but I also need a 5 to build the 10. So I would need these 3 numbers to be able to make 2 times 3. There's the 2 times 3, and 2 times 5, 2 times 5. No repeats necessary. So there it is. 2 times 3 is 6, times 5 gives 30. And I know some of you can do these in your head. I'm just showing you. You'll see why in just a little bit here. All right, here's one that's got 15 and 24. So 15, that's a 3 times 5. 24 is a 3 times 8, and 8 is 3 2's. So the prime factorization of 24 is 3 times 2, which is 6, times 2, which is 12, times 2, which is 24. And now I'm going to make my LCM or LCD out of these. And this one now I'm going to need all 3 2's. That's part of my 24 and the 3. And then the 3 is covered, I got that, but I need a 5 in there. That way I can make my 15. 3 times 5 gets me the 15. These 3 2's and the 3, that gives me the 24. All of these together, let's see, 2, 4, 8, 24 times 5, 120 would be the LCM, which would be the LCD if it was a fraction. All right, as you can imagine, it's not going to be just numbers. We're going to be putting letters into the mix. Whoops. So this first example, and I know it's matched up with example 2 problems in your book. They say find the LCD, or actually LCM for these, they aren't in fractions yet, of 2x squared minus 8x plus 8. That's our first trinomial, and then they give us a binomial, 15x squared minus 60. And now we're supposed to find the LCM of these 2 expressions. So I'm going to factor these so I can see its pieces, just like we were doing prime factorizations up there with when they were just regular numbers. Now I'm going to do factorizations. Excuse me. I notice all these are even, so I can take out a 2. And that whittles it down to x squared minus 4x plus a 4. And then this is factorable. This is actually a perfect square trinomial. So this is a couple of x minus 2's. And then we got that 2 on the outside. We factored out that GCF. This also has a GCF of 15. And that whittles it down to x squared minus 4. And then this is difference of 2 squares. So this gives me an x plus 2 and an x minus 2 when I factor that. And now to build my LCM, that's an M there, not too good. I've got to have all the pieces that I can build either one of these from. So I need a 2, and I'm going to need both of those x minus 2's. That gets me my first one. I need a 15. I'll put that in parentheses to remind me it's getting multiplied in there. And then I'll need an x plus 2, because there isn't one yet. But I already have my x minus 2, so I don't need to repeat that. So this LCM has got a lot of pieces to it. I'll put the regular numbers together. That gives me a 30, 2 times the 15. And then I got this x plus 2. And then I've got a couple of x minus 2, so I'm going to take a shortcut and just say that's squared, so I don't have to write them twice. If you wrote it out twice, no problem, same thing. So there's your LCM, and the order of these binomials here at the end, that doesn't matter, it's random. All right, that's getting us closer to the harder problems, but we're not quite there yet. So this next example goes with example 3, where now we're going to add. Whoops, sorry about that. So this is example 3, where it's going to be a fraction now. 1 over 3x squared plus 21x plus 30. And then the second one's going to be 4x over 3x plus 15. So this I have to determine the LCD of this problem, so I'm going to have to do some factoring here. So I'm going to factor out the GCF of 3, and then this is x squared plus 7x plus a 10, which then can be factored. That looks like it's an x plus 2 and an x plus 5. And then the second one here, the 3x plus 15, I can factor out the 3 and get x plus 5. So I've got two common things, but then this extra x plus 2. So actually this first fraction is the least common denominator. That's kind of nice. We won't have to change anything there. I am going to write it as its pieces, its factors. And then we're doing plus 4x. We've got the 3 and we've got the x plus 5, but I needed that x plus 2 to get this to be the least common denominator as well. So now I can put all my numerator stuff together and then just use this common denominator as part of the final answer. So I got 1 here, then 4x times the x, I get 4x squared, and then 4x times the 2, I get 8x. And then this is all over this least common denominator of 3 times x plus 2 times an x plus 5. And then I'd probably neaten this up a little bit on top and get it in standard form. So I'd start with that 4x squared, add the 8x second, go with descending order because it's a polynomial up there. And then these, no sense in multiplying this out, although you certainly could. So there's your final answer. And if you wrote it instead 4x squared plus 8x plus 1 all over, and then had it all multiplied out to 3x squared plus 21x plus 30, that would be okay too, but you don't need to, don't bother. All right, whoops, didn't show that very well. There we go. Okay, last example of this type, dealing with the same idea but subtraction. So this would be an example 4 kind of problem. So they throw in subtraction sign here. So I've got 2x all over an x squared minus 2x minus 3. And then I'm subtracting now a 3 over and then a 4x plus 4 for my second denominator. So again, the first thing, factor these denominators and to figure out our LCD. So this is going to be x minus 3 and an x plus 1 when I do that factoring. What times what makes the negative 3? Then it will add up to be, or subtract in this case, negative 2x. And then this other one, that's a 4 that can be factored out and give us an x plus 1. Alright, so both of these original fractions do not have the LCD, so we're going to have to change both of them. The LCD for this then is going to need the 4, it's going to need the x plus 1, and it's also going to need the x minus 3. I can build both of these out of this, no repeats. So 4 and the x plus 1, that gives me this second one, and the x plus 1 and the x minus 3, that gives me this first one. Alright, almost there. So I got 2x all over this x minus 3 and x plus 1, but to be able to subtract these, I've got to multiply top and bottom by 4 to get that to be the least common denominator. And then now it's a minus sign. You got the 3, I might as well put that over the 4 times the x plus 4. That's missing an x plus 5. So I'm going to do x plus 5. Oops, not plus 5, minus 3, my bad. Looking at that previous problem by mistake. And then x minus 3. What I do to the bottom, this is a minus sign right there, by the way. What I do to the bottom, I have to do to the top to keep these fractions the same value and also to get them least common denominators. Alright, we're almost there. This is an 8x minus a 3x plus a 9. Do you see how this minus sign gets distributed to this minus 3? All over the 4, the x minus 3, and the x plus 1 least common denominator. Now simplify the numerator if you can. So these are like terms I can put together. I get a 5x plus 9 on the top, and then my least common denominator. Again, don't bother multiplying this all out. Leaving it as factors like this is useful. So there's the best answer right there. But if you wrote it to be the 5x plus 9 on the top still, but then multiply this out, you get 4x squared minus 8x minus 12. That'd be an okay answer too. Best one, that first one, this would be okay. Alright, that's most of the lesson. There's one last thing about complex fractions. So, complex fraction is a fraction that has a fraction in the numerator, or a fraction in the denominator, or fractions in both. And those are the types we're going to be dealing with here. So for example, what if I had 1/2 divided by or over 3/4? There I have a fraction in both the numerator and denominator. When there's a fraction in either or both, like this case, it's not considered simplified until you make it into a regular fraction. So there's a couple ways to do this. One way is just to remember the definition, which says that if I'm dividing by a fraction, I can keep the original fraction and change it into multiplying by its reciprocal. So I'm just using the definition because this fraction bar, that's like saying it's divided by. So if I'm dividing by 3/4, that's the same as multiplying by 4/3, and that gives me 4/6, which is 2/3. That is a simplified fraction. So when you're thinking 1/2 divided by 3/4, you actually can simplify that to 2/3. You can do this on your graphing calculator. If you just type in 1 divided by 2 and then divided by 3 divided by 4, then it'll give you a decimal answer, and you can go to that math key and hit fraction, and it'll get it down to a regular fraction. There would be another method to do this. So if I had 1/2 again divided by 3/4, I could multiply top and bottom by the reciprocal. That's fair. 4/3 over 4/3, that's 1. And so this 3/4 times 4/3, that all turns to 1, which is going to disappear. I get 4/6 on top, which then gives me my 2/3 over 1, which is just 2/3. Could simplify it that way. Alright, let's put some letters into the mix here so we can get some practice with that. So this would go with example 5 questions. And the first one here will have 1 over x over y. So as I mentioned earlier, with complex fractions, there could be just a fraction in one part of it. So in this case, it's the numerator that has a fraction in it, the denominator doesn't. In order to solve this, personally, I would just make this y be over 1, so I could have fractions top and bottom, and then multiply by the reciprocal, which is 1 over y, both top and bottom. 1 over y divided by 1 over y, that's just 1, so that doesn't change the value. The y's cross out, the 1's cross out, I just get a 1 here, and then I get 1 times 1 on top, which is 1, and x times y, which is xy, and then this 1 over xy over 1 is just 1 over xy. Anything over 1 is just itself. Alright, so that was one of 3 complex fractions. Just 2 more to go here. Whoops, too far. Alright, here's part B, or the second one here. 1 over y over 3 over x. So here's one where I have variables top and bottom, and I've got fractions in the numerator and the denominator. So again, I would choose to multiply by the reciprocal on both top and bottom. The x's cross out, the 3's cross out, so I just get a 1 downstairs, and then I get x on top and a 3y on the bottom. That's a y there. And then this x over 3y divided by 1, that's just x over 3y. Alright, last, I guess, 2 of these. I'm going to show you 2 methods, so it's 2 different ways of doing the same problem. Alright, so we got 1 over x plus 1 over y in the top of our fraction, and then a 2 over y minus 1 over x. Alright, so first way that I would do this is I would simplify the top and bottom. So I would kind of pretend like, alright, it's just the numerator I'm going to solve out. And so to do that, I got to get a common denominator. It is xy, so I'm going to multiply top and bottom by what's missing. So I need a y to be on this. So this is going to be 1 over x times y over y. That'll get me an xy there. Plus 1 over y times an x over x. That'll get me the xy in that fraction, and then I'll be able to put those together. So this becomes a y plus x all over that common denominator of xy. That's just the numerator part. Now I'll just start over and do that to the denominator part. Same common denominator. So now this 2 over y is going to have to be multiplied by x. That gets me xy, which is the common denominator. And now it's minus, and then this 1 over x gets multiplied by y over y to get that xy common denominator. That gives me a 2x minus y all over xy. And then you can multiply top and bottom by xy over xy on the top over 1 times xy on the bottom over 1. And the xy's cross out, and we get y plus x for my numerator result, and I get a 2x minus y for my denominator. And there's your final answer. That was one method. Simplify this addition in the numerator first, do the denominator same thing, and then simplify that where you have the common denominator. You can just multiply it, top and bottom by it. Or you could change this and multiply by the reciprocal, which is the second method I'll show you. Alright, so same problem again. You can decide which way you like best. There's several ways to do these, as you can see. So I have that 1 plus x over 1 plus y top. So this is just this is method 1, and the second one here is going to be method 2. So it's the same problem, just 2 different ways to do it. See which way you like best. And then I have the 2 over y minus 1 over x. And now this trick says, all right, if you multiply, that's a parenthesis there, if you multiply the top and bottom by the LCD, that's fair, because x y over 1 over x y over 1, that's just 1. Something over itself is 1. And so this changes the method a little bit and allows you to get the numerator and denominator to just not be fractions quicker. Personally, I kind of like this way better. So if I do 1 over x, I'm doing the distributive property now, times xy, the x's cross out, and I get a y. If I do xy times 1 over y, the y's cross out, and I get an x. If I do that same process here, the y's cross out, and I get a 2x, and the x's cross out, and I get a minus y. And there's my final answer, y plus x over 2x minus y. All right. Last thing here, pages 507 to 8, numbers 4 through 30 even. Good luck, have a great day, do everything your parents say.